Hello and welcome to this new video. My name is MrGrey and I'll be taking you through some entertainment. In today's video we're going to talk about neutron stars. We're going to concentrate on Krapelzar, the most famous neutron star ever known, and at the end of the video we will create our own neutron star and replace the sun with it. So let's get started. So this is Krapelzar, like I said, the most famous neutron star to the science. What do we know about Krapelzar? This is, by the way, a real star. It's about, or a little bit more than 7,000 light years far from the sun. Has been discovered in 1968. And this is a young star. So there are Chinese, Korean, and Persian records. The records say that in the year 1054, a supernova has been seen from the planet Earth. People could actually see a supernova from farther away, of course, in the sky. And the modern science have discovered that because of this supernova, a little star has been born. And that's the Krapelzar. It's not a regular star, it's neutron star. And it's at the center of Crab Nebula, the nebula that came after the supernova. Yeah. What do we know about this? We know that it's relatively small. It's really small. The radius of Krapelzar is based on universesandbox, 11.5 kilometers. If we change that to meters, that's 11,545 meters. Trust me, there are so many cities on our planet that are bigger than this star. This is how small it is. Yet, do not be fooled. This is an object you do not want to mess with. Neutron stars are aggressive. Really, they are considered even to be the second strongest objects in the universe after the black holes. If we look at the temperature, let's change that to Celsius. They are insanely hot. The surface temperature of Krapelzar is 394,531 degrees Celsius, almost 400,000 degrees. What does that mean? I'll tell you what that means. Let's add the sun to know what that even means. Now, the sun has a surface temperature of 5,506 degrees, while Krapelzar, like we said, almost 400,000 degrees. Like on a sunny day, you would go out, to the beach to take a walk or whatever, and sometimes it feels really hot. It feels so hot, although our sun is so cold compared to Krapelzar. So imagine getting anywhere close to that object. Let's get back to it, and let's find out what do we know more about it. We also know that neutron stars rotate super fast. If we go to the rotational period, I'm not gonna even try to read this number, we will just change it to second, and we will find out that Krapelzar finishes one rotation every 37.3 seconds. So per minute, every half a minute, almost a little bit more than half a minute, it will rotate, it will make one rotation around itself. They rotate super fast. Now look, we are running 1 second per second. This is realistic time. We are going in real time, and this is how fast it rotates. Now back to the size of it. We said it's so small. Let's look how that looks like compared to our moon. Let's add the moon next to it. Okay. Yep. Let's spawn the moon right here. Time is paused, and I'll just keep it paused, because if we play the hit button, a miss is going to happen. We will not play a simulation yet. We will just look. This is our moon, and this is the star. See? Now keep in mind, our moon is 1/6 the size of our planet, meaning our planet is going to be 6 times bigger than this circle. And let's add our planet. So, yep. This is the star next between the moon and our Earth. I meant it when I said there are many cities that are bigger than this little star. Now let's say Krapelzar on a random day will spawn at a distance of about 100,000 kilometers far from our planet. What is that going to do to our planet? Let's keep an eye on the average temperature basically of the planet, and keep in mind this simulation is going in real time, second per second. We're not going fast in time. Let's hit the play button and see. The average temperature is rising insanely. And are we going to rotate the star? After 20 seconds, we have crossed 1200, 300, 400 degrees, and it's getting hotter and hotter, and even the temperature will rise faster because the closer we get to the star, the faster the temperature will rise. And yes, so within less than a minute, we are going to vanish. Maybe half a minute, I don't know. If this happens in real life, we will not even know what happened. We will just vanish. And look at what Krapelzar is doing to our planet. I'm not going fast with time, by the way. Like I said, the simulation is telling me that Earth became a star. This is what's gonna happen. And the surface temperature crossed 3 million degrees Celsius. Let's continue this simulation, and let's now speed up time a little bit. This is our planet, ladies and gentlemen. It's no longer a planet, it became a neutron star itself. Can we find Krapelzar? No, it vanished. It became part of the planet, and they both became one huge neutron star. What could actually happen if instead of the sun we had Krapelzar? Let's try to find out. Replace object, and let's find Krapelzar. Yep, replace. Now we are not going to go second per second because the reaction is going to be super slow. We are talking about now the entire solar system. Let's hit the play button and see. Let's keep an eye basically on the trails. Look, the orbits of many planets shrinked. Now Mercury and Venus are orbiting the new sun, let's call it, really faster. Our planet awkwardly is losing temperature, and it's losing it fast. Let's speed up time even more, and our planet will just freeze. Now, we have seen earlier that Krapelzar is way hotter than our sun, but why did our planet freeze? Is this not supposed to burn us? I'll explain why. If we got close to Krapelzar and turn what's called habitable field on, this is how it's gonna look like. What is the habitable field? So when I turn that on, we notice there are 3 highlighted areas with different colors. This shows me that the objects within the red range, they are too close to the star to support life, too close, too hot. The green area means decent distance to the star to support life, and the blue means, of course, too far, so cold. So it's gonna be like super cold. Planets here cannot support life, only within the green range. If we go further, look at the Earth. It's so far from the star, from the habitable area, to get any heat. That's why our planet started freezing. Although Krapelzar has an insane gravity, it will not be like placing a black hole. Like neutron stars have really strong gravity, but they are not as strong as the black holes, so it will not tear the solar system apart. It will just kill any possibilities of life on in our solar system. Now we also notice that the objects at the edge of our solar system have escaped the gravity of the sun, of Krapelzar. This is realistic, I believe, because Krapelzar at the end of days is super small. We're going now to create our own neutron stars. If you use Universe Sandbox, consider this to be a little tutorial. To create a neutron star, we only need a gas giant. We can go for Uranus, Neptune. Let's go for Neptune. Alright, and we're gonna do only little changes. So in the mass, we can change that to solar mass, and let's change the mass of Neptune 3 times the mass of the sun. And boom, we already have a neutron star. Why do I want to create my own Neutron Star? To be honest, Universe Sandbox, although it's a beautiful app, but it doesn't really show objects the way they really are in reality. Neutron Stars actually in reality look like this. They have this effect, you can see. It is beautiful. However, let's continue working on our Neutron Star. We go to radius. We're gonna make this a little bit big. Let's, like, we already learned that Neutron Stars actually have a small radius, but we're gonna make this kind of big. Let's make it 10 times the radius of the Earth. So yes, regarding the temperature, we can change that the way we want. This is a little beautiful thing to see. I give this Neutron Star 1000 degrees for its surface temperature, and it turned into orange, as you see. It has a blue effect, but it is orange. This is really something beautiful to see, but we are not going to stop here. We're gonna make this star way too hot. We're gonna make it 1,000,000 degrees. All right? Now, this is what I call a neutron star. Regarding the rotational period, we know that neutron star rotates super fast. I don't know how fast can we make this. We don't want it to tear it apart, but let's change this to minutes and let's make it make a rotation every minute. 10 seconds. All right. Okay, we're gonna stop here. So our neutron star makes a rotation every 10 seconds. And let's call that, let's change the name of it. I don't know, what are we gonna call it? I'll just give it my name. I don't know. Yep. So we have a neutron star called MrGrey. It's 1,000,000 degrees. And it is going to take the place of our sun. This is what we are going to try to do. Now we're gonna go to the sun, replace it with MrGrey, and see what is this going to do. Okay, I just paused time because I don't want to see a reaction yet. Let's replace it with MrGrey. Yes, sir. And this is how it's gonna look like. We have MrGrey up in the sky. This is funny. Let's head to our planet and see how that looks like. One of the comments told me I can land on objects, but the landing here is not going to be like landing on objects in space engine. Thank you for the comments. Let's land here. Yes, we can land. Can we see? Yes. Okay, let's take a better look. Hide the trails. Close this list, this one too. And from the surface of our planet, if this neutron star, which we have just created, was there instead of our sun, this is how it will look like. Imagine one day looking up and seeing this. Isn't that something beautiful to see? Wow. You might think, wow, I want to see that. Well, trust me, you don't want to see that, because we're gonna now play the simulation. Okay, I'm gonna hit the play button, and again we're gonna keep an eye. Basically, the most important planet for us in the solar system is planet Earth. That's where we live. That's why I always just like watch our planet and how it reacts. So once I hit the play button, wait a minute, what happened here? Mercury turned into fire. What about planet Earth? The temperature is rising insanely. We are going in real time, second per second. The temperature is rising really insanely. What about the life likelihood? Look at how fast this is dropping. Okay, let's go a little bit faster with the time and see. Wow. Okay, we already know our planet is cooking. What about the other planets? Mercury. All the blue dots you see, this is Mercury. It turned into fragments. MrGrey turned Mercury into fragments, and I think it's gonna do the same to Venus and at some point to the Earth. Let's go even a little bit faster. Fragments everywhere. Yep. Whoa. Okay. Venus disappeared. Earth also disappeared. Mars disappeared. Now we have Jupiter and Saturn. Okay. I told you before, it was a beautiful view, but it's not something you want to see. Alright. Let's go real fast with the time. So yes, an insane gravity just killed our solar system entirely. Nothing is escaping this gravity. Look, even the the furthest objects at the edge of the solar system, they could not escape the gravity of this neutron star. There are only two objects that could create an orbit around this star, and that's Uranus and Neptune. I do not know if at some point they will also vanish. Well, Jupiter itself could not survive. Uranus and Neptune, however, managed to survive with a crazy looking orbit. Look at the way they are orbiting. I don't know if you can see that. I think it's clear. And taking a look at the solar system from far away, we turned into a nebula. Our solar system became a nebula with only 3 objects, neutron star and 2 fighting planets. So this was the end of the video. Hope you guys enjoyed watching. Write me in the comment section if you want me to do any specific simulations. Please don't forget to like the video and subscribe to the channel. And I will be seeing you in future videos.